If you just do it, it'll turn out okay. And we did a poll, and this is the results.
Yes. Well, first, might just be good to say hello there, folks. Hope you're doing well.
Yes.
But here, you go ahead. You go ahead.
We have three choices. Going a deep dive in the Pacliosaurus, 32% got the vote. Ceratosaurus is explored, 38% of the vote. And the Brontosaurus, Apatosaurus thing, 30% of the vote.
Mm-hmm. Yep. So this week we are doing the Wow, I thought I could roll a Spanish R there, but apparently I couldn't. Today we're talking about ceratosaurs, which are a really weird and really cool group of dinosaurs. So I hope everyone likes this.
Yes. Real fast. Please save all of your questions to the end so we don't have to scroll back to get to them. But if you donate the link below, we will answer your questions immediately or super chat. Either way, we will answer your questions ASAP. Well, otherwise, save your questions to the end.
Well, I mean, I think it's fine if people ask questions throughout. Would you be able to keep?
Because last time we did that, we had to scroll back for them.
Would you be able to copy them down in like a Word document or something?
Yeah.
So then, yeah, we can do questions at the end. If anyone has a burning question that they really want an answer to, feel free to send in a super chat and we'll answer it right away. Before we get started though, would you mind making my camera big for a second?
Sure.
Really quick, I just want to say, well, first, howdy there, folks. Hope you're doing well. Second, I am trying to raise money for a little museum that I'm very attached to here in Grable, Wyoming. This is their hat from their museum. There's going to be a link in the description of this stream to their website. If anyone would like to make a donation there, please do so. It's a little museum that I'm really hoping to help grow. So yeah, just a little announcement there I wanted to make. All right. And I can send you the link too if you want. And also to address something in the chat, Nessie might be here later. Not sure. She had to run up to Montana for something today. But if she can join us, then she will. And she'll show up well a little later into the stream.
You said you might. But you also said you had you might have other guests, but they not show up.
Yeah, we did invite, or I did invite more people. Haven't heard back from any of them, but never know. We might get a surprise guest.
All right. Awesome. Back to the Center program.
Yes. Alrighty. So I guess, yeah, we're about 5 minutes in. Might as well get started with the core presentation today. So today we are talking about the ceratosaurs, which are a group of theropods, and I wouldn't call any of them normal, at least as far as theropods go. Every single ceratosaur appears to be odd in one way or another, so it's just a whole group of oddballs. So I hope y'all are excited because today you're probably going to see some dinosaurs you've never seen before.
Unless, fun fact, if you ever watch Digimon, the Greymon is a Ceratosaurus.
Really?
Yes.
Huh. I mean, that's not super surprising. Ceratosaurus itself has been, we'll see it later in the stream, but Ceratosaurus itself has been in a lot of media. It's been in games, movies, shows. I think it was something Thunder Mountain, a really old movie, like from the early days of Hollywood, had a Ceratosaurus as its main dinosaur villain, which I think is kind of cool. And the other odd and notable members of this group have also been mentioned or referenced in other media, some of which we can call out when it's time. For now, though, I wanted to give a quick disclaimer before we got started. So, it was brought to my attention recently that in some of our past streams, I spoke pretty authoritatively on some dinosaur relationships. Oh, Caden got the movie, The Ghost of Thunder Mountain. But it is important to remember that the proposed relationships between all dinosaurs are all hypotheses. They're not proven, they're not facts, and what we know can change based on future evidence. That's just how science goes, and especially in a field that has to work with bits and pieces like this one, it's inevitable. As an example, 30 years ago, we weren't sure that tyrannosaurs were coelurosaurs, a specific group of theropods. Some people actually thought that they were allosauroids, the topic of our last dinosaur stream, so like Allosaurus. They thought they were related.
Sorry, my headset went out, so I didn't hear anything you just said.
It's all right. This is more for the audience.
Okay.
Now, with all that said, what I'm presenting to you all in these streams is the current consensus on dinosaur relationships. They're based on a ton of evidence, macrofossils, so skeletons, microfossils, features of the bones, and also it's based on genetics and proteomics when we have them. Proteomics is the study of proteins. Case in point, T-Rex, we have some tiny scraps of collagen protein from T-Rex, and they are most similar to a modern ostrich, showing that, hey, dinosaurs are, or well, kind of showing that birds are dinosaurs, and specifically theropod dinosaurs. If new evidence comes out and it disproves something I have said or will say in these streams, I will pin it in the comments so everyone knows. And again, despite the fact that paleontology studies extinct organisms, it's very much a living field. And I wanted to say thank you to the friend who reminded me of that. So that's a little disclaimer. Again, none of this is absolutely certain, but it is very well supported. And that's kind of just how things go in a lot of biological fields.
Things change and are updated.
Yes. Especially in paleontology. We don't have access to all the fossils in the world, and we never will. With all that said, oh, go ahead.
Say, or the DNA, or the DNA of the extinct dinosaurs. We have them for the living ones, but not the extinct ones.
Yes, and the DNA of birds shows that their closest relation or closest living relatives are crocodilians, which we would predict given the fossil evidence.
Yep. And to more of that, check out our crocodile episode.
Yeah, that was a long time ago. All right. So, quick review before we get into the ceratosaurs themselves. Ceratosaurs are theropods. Theropod dinosaurs are, as far as we know, an entirely bipedal branch of Saurischian dinosaurs. Remember, Saurischians are the ones that, at least ancestrally, have a pubis bone, so part of the hip, pointing forwards. I don't know if this will be reversed for anyone watching, but it juts out in front of the hip. The other group of dinosaurs is ornithischians, where the pubis points backwards towards the tail. Saurischians are the only living dinosaur lineage, and they are very diverse. I mean, people might look at an Allosaurus skeleton and say, "Oh, that's just a small T-Rex or something," but no, they're extremely diverse in terms of what they hunted, where they lived, how they lived, and all other kinds of things.
Speaking of our past thing, related was our last clade to this clade?
So that's a good question. Really quick, I'll just go ahead and do this. So here's a box highlighting today's focus, the
Okay.
ceratosaurs. And just checking, yep, they can see my mouse. So, so the way all animal relationships work, they're all tied together in some way along a family tree. And it splits like an actual tree. At least that's how we draw them. Each of these words here is the name of a group of dinosaurs. And as you get farther and farther to the right, the more focused that group is, so the more specific it is. For example, we have tyrannosaurs right here, but even tyrannosaurs are split into at least two major groups, maybe more.
Mhm.
Within this tree, we have theropoda, so everything that is a theropod, the bipedal, usually meat eating dinosaurs. There are neotheropods, which have generally longer legs, uh, more pneumatized skeleton, stuff like that. Within neotheropods, we have the avarostrans, which are even more pneumatized. They have lots of air spaces in their skeleton, both in the head, the vertebrae, and in the limb bones and ribs. In some, just about every bone is full of holes. Ceratosaurs are avarostrans, so they have that holy skeleton, but they're not within the group that the allosaurs were in, the tetanurans. Tetanurans have ossified tendons in their tails, which tendons are what muscles pull on to make your body move. Sometimes those can be ossified or turned into bone in whole or in part. That's usually to make areas stiffer. So all the tetanurans have stiffened tails. Ceratosaurs do not. And that's part of what makes them unique among derived theropods. And focusing more on the ceratosaurs, they're a very long lived group. The earliest ones we have are from the Middle Jurassic, and they continue all the way to the end of the Age of Dinosaurs. Ceratosaurus doesn't, it dies out in the late Jurassic, but its relatives continue on.
Uh,
And
But there's sorry, real fast. But there is no current living clade today. Oh,
correct.
okay.
The only group of dinosaurs on this entire chart that is still alive is right here at the bottom with the birds. Ceratosaurs are up here, and the last ones go extinct at the end of the Cretaceous about 66 million years ago. With that said, ceratosaurs are also incredibly diverse. I mean, they were around for about 100 million years, if not longer. So that's almost two Cenozoics. That's almost two ages of mammals. They had that much time to diversify and change. And they really did. Some of them got really weird. So they kind of act as a good illustration of theropod diversity just in a little microcosm. They go in directions that every other, or that we see, sorry, they go in different directions that we will see again and again in this series because other lineages specify into the similar niches. With that said, with how long lived they are, we will be jumping kind of back and forth in time. It's not going to be as simple as our last episode on the allosaurs, but I hope people can follow along. Okay, that's just highlighting ceratosaurs. Okay, so now we are within Ceratosauria, and just like with the previous image, this is a tree. The problem is, and this is part of why I wanted to make this disclaimer at the beginning, the exact relationships within Ceratosauria are a little contentious. Different authors have found different results. So the exact grouping could change in the future. With that said, within the group that is commonly referred to as the ceratosaurs, there are three distinct groups, and we're going to be going through them one by one. The first one is the noasaurs. These are small, speedy theropods who get really diverse, and in fact, they split into their own smaller groups, which we'll meet in a little bit.
So were the Noasaurs on Noah's Ark?
No, I don't think they were. The ceratosaurs themselves are larger. They're about mid-size for a theropod, getting to about 20-ish feet long, though there is a bit of a range. Most of the members of this specific group are pretty fragmentary. The only one we have a really good representation of is Ceratosaurus itself. So that's the only one I'll mention in this. But there are more out there if anyone's curious. And then the last group are the Abelisaurs. This group includes the largest members of this group, and they have a lot of really weird characteristics that they all share. Like, when I say ceratosaurs get weird, they get weird. You will see things in this stream that you will not find in any other group of theropod. I will be definitive about that. At least from what we know so far. So, as of current stream, this is arguably the most bizarre group of dinosaurs, I will say. Now, if you do go to Wikipedia and you try to look up more about these dinosaurs, some articles will say Ceratosauridae is a family. So that's a taxonomic family. Like you have a genus, you have a species, you also have families. Like there's the family Carnivora in mammals, and that's cats, dogs, bears, things like that.
Yeah, clades are a lot of clades are unnamed too.
Unranked. They have names, but they don't have specific rankings, and that's actually what I was about to mention. Some researchers have Ceratosauria. I'll just say Ceratosauria as a family. Some have Noasaurs, Ceratosaurs, and Abelisaurs as their own separate families within a larger clade, which would be Ceratosauroidea, typically. Oid is a group of families. Like I said, people disagree, so I'm just going to call them Ceratosaurs, Noasaurs, and Abelisaurs. And for my fellow phylogeny pedants, I'm sorry, but considering how contentious this appears to be, I'm not going to be definitive on it.
Yeah. You only get name things. When me and Erica did the primate thing, all the way from humans all the way to the all the apes, all have the homo and homo. I can't pronounce them all these different names. Also of H's. So it's like
they're all hominids,
yes,
right?
Yeah,
yeah. And Hominidae is also a family, but should it be? I don't know. It depends on who you ask.
Yeah.
Also, I see Nessie is in the chat saying she likes the Cerato from JP3. Yeah, I agree. It's a fun design, but it's not really a good Ceratosaurus.
So is that the third movie or the sixth movie?
That's the third movie.
Okay.
Oh, and Thomas Rutledge points out, if the age of dinosaurs was 1 mile, which is about 165 million years, then 5,000 years would be less than 2 inches. Yeah, it's there's an analogy that compares the whole history of Earth to a calendar year. I think dinosaurs died out last Thursday or something like that, if we are on December 31st, they died last week. Humans first evolved earlier this day, and the entirety of recorded human history has been in the last minute of the last hour of the last day of the year. It's a I forget who made the quote, but it's honestly a pretty good analogy. So anyway, Ceratosauria, the big group we're covering, these are the smaller groups within it, and we are going to start. Well, we're actually not going to start by focusing on any of them. First, I want to go over what they all share. So everything on this list is a ceratosaur trait. Oh, and Caden has the person who said it. Carl Sagan. Thank you. I should have known it was him. So ceratosaurs share a few features that set them apart from basically all other derived theropods. And we might see similar traits in some later theropods, but how they go about these traits are weird. So, for example, all ceratosaurs that we know of have a four-fingered hand. All other derived theropods, so all tetanurans, have 3 fingers, 2 fingers, or 1 finger. All of them. Ceratosaurs are the only ones with 4. They all exhibit a reduction in arm length. So the arms get short early on in the group, and in some cases, they get really crazily short. Well, first to illustrate the 4 fingers, here is Machikosaurus, which we will see again later in the presentation. To show the arm length, we have this little toy here of an Abelisaur, so one of the later ceratosaurs. And the funny thing is, these arms aren't small enough. They look like tiny nubs, but they're not small enough. It shouldn't have an elbow. I'll repeat that. This animal should not have an elbow. They also often have really short hind limbs relative to their overall body length. So this chart here is showing a bunch of theropods from the Morrison Formation, which we'll be visiting again later. Let's see. Ceratosaurus is here in yellow, and it's standing here right next to this green dinosaur called Marchosaurus. Now, even though Ceratosaurus is over a meter longer than Marchosaurus, it's maybe 10 to 15 centimeters taller at the hip. It is really short, but lengthy, and that's something all ceratosaurs have. And they also often feature some wacky skull modifications. Most of these guys will have a crest of some kind, and if they don't have a crest, they're doing something weird with their mouth. Every single one of them. So, to start with our first group within Ceratosauria, we're going to begin with the Noasaurs. So, according to some studies, these are the earliest diverging group of ceratosaurs, and they get weird straight away. As I said before, they're split into 2 major groups. There are the Elaphrosaurians, which appear to be herbivorous, and the Noasaurians. The Noasaurians are carnivores, like the other ceratosaurs, and they do weird things with their teeth. But so do the Elaphrosaurians, as we'll see. They're known from both the Jurassic and Cretaceous, and appear to have been pretty successful, whatever they were doing. We have members from both groups from the Jurassic and Cretaceous. So they don't really get a lot of press, but they were apparently pretty successful. And actually pictured here is an Elaphrosaurian we'll get much more familiar with here in a moment. This is Lemusaurus, with some babies here in the foreground and an adult behind. And if you look closely, it has a beak and it doesn't have teeth.
Mm.
So, Lemusaurus inextricable. So I hate the species name. Lemusaurus inextricabilis. Inextricabilis. That's it. It's a weird dinosaur with a weird name. For starters, its name translates to the mud lizard that could not escape because it was discovered in a mud pit. And not just any mud pit, it was discovered in a mud pit that formed from a sauropod. So, big surprise, sauropods were big. And when they took a step, sometimes they could sink pretty far into the mud. And it would just create these death traps for small animals. Especially in certain formations in China, we just have a series of sauropod footprints sinking into the mud with the corpses of smaller animals that fell in. It's bizarre. But, well, I'm just going to list off a few traits that Lemusaurus has. Lemusaurus is small. Lemusaurus is bipedal. It's predatory as a juvenile, but it's herbivorous as an adult. The juveniles have teeth, the adults do not. All of those individually aren't weird for a dinosaur. They occur in multiple groups. All of them together is something that, to my knowledge, we do not see in any other dinosaur. And not just any other dinosaur, not in any other vertebrate.
Hmm.
And
That's a big group.
yeah, just vertebrata. Losing your teeth as you age and resorbing the pits for the teeth is something we, as far as I know, we have just never seen in any other vertebrate. Lemusaurus is bizarre. And really quick, here is a photo of a juvenile skull versus an adult skull. You can see the little teeth here in the juvie and not in the adult. And I will say, we are certain that these are the same species because we have dozens of Lemusaurus skeletons. We know they are the same thing. We have a complete growth series from juvenile to adult. They just do this. In fact, here is a chart from a paper that is linked at the top of the screen. And just so people know what we're looking at, these are the 3 tooth-bearing bones in a dinosaur. We have the maxilla, which is where you have your upper teeth, the premaxilla, which is the tip of the nose, which actually humans don't have a premaxilla. It's just something that at least primates lose, and yeah, primates lose. At least apes lose. And the dentary, which is the lower jaw. Well, the part of the lower jaw in dinosaurs that holds teeth. Up here, all of these are a juvenile. This is a subadult, and you can see the teeth are kind of wearing away. The teeth are in orange. And then this is a fully grown adult. The teeth are gone. The tooth sockets disappear. It just stops growing teeth, and then the pits swallow back up. I'm not sure I can really convey how just weird this is, to be honest with you. It's, again, we don't see it in any other dinosaur. And I actually really love in this art right here, they reference that. Because you can see the juvenile here snacking on a little lizard, and the adults back there munching on some plants. And honestly, this is actually probably a pretty probable reconstruction of these guys.
So these guys might have some of them might have been herbivore, at least omnivores. At least they're eating plants.
The juveniles are likely carnivores, and the adults are herbivores. And actually, I this figure here, the figure it's sorry, this whole image is actually from a blog. These skeletons are from the same paper that the tooth photo is from. So the juveniles have deeper skulls with more powerful, relatively muscle attachment points. They have a straight dentary, and they don't have gastroliths, which is something we find in a lot of, especially herbivorous dinosaurs, to grind up food. The adults have a curved dentary, and it's curved downwards. That's usually not good for catching prey. They have a longer skull, which is something we see in a lot of herbivorous dinosaurs, and they have gastroliths.
Mm.
Their pubis also changes. It gains a really strong boot, which is an extension at the front, which could be to help hold more guts for eating plants. Now, I will say, changing as you grow up is not a surprise. Sorry, changing as you grow up isn't a surprise. Humans do that. If you scaled a baby up to an adult size, you'd be able to tell it was a baby, right?
Mm-hmm.
That's normal. Change to this degree is not normal.
Mm-hmm. So
Now,
is
an important.
sorry.
Go ahead.
So this is one of those rare. I won't say rare because it could be more thing, but what, I'll say rare in quotation marks. Plant eating theropods.
Not really. Herbivory appears a lot in theropods, actually. Yeah, there are several major groups we'll meet later on that are entirely or at least mostly herbivorous,
Okay.
like the therizinosaurs, the oviraptorosaurs, and quite a few modern birds. Becoming
Well,
an herbivore isn't
why?
weird.
Yeah, well, I know bird. I know some birds are plant eaters, but I didn't know that a lot of these pre other sides of the family went down this lane too. Because usually you don't see you don't
Um,
hear much about them, at least in the
that,
public.
that's fair. I mean, just pointing from this chart, so we have the nosaurs up here. Some of them turn herbivorous. Going down, we have the ornithomimosaurs. A lot of them appear to be herbivores. The alvarezsaurs are contentious. The therizinosaurs are entirely herbivores, as far as I know.
Mm.
Oviraptorosaurs, and even some troodontids down here, so raptor-like dinosaurs. Some of them may have been at least omnivorous. And then again, there's just birds, which I'm not going to say most, but a lot of modern birds are herbivores. Also, really quick, Nessie is saying a lack of evidence is not evidence. I agree. I'm not sure what that's referring to. If that's referring to me or someone in chat. Do do do. Anyway, Lemusaurus though is an extreme example, but a good example of something that we see a lot in dinosaurs, which is called ontogenetic niche partitioning. Now, it's a very long term, so I'm going to break it down. Ontogenetic refers to an animal as it ages. Ontogeny is the study of how things age. Niche is what role you play in the environment. Like, are you a predator? Are you an herbivore? Etc. And then partitioning is a separation. So it's the study of how different life stages change their position in the ecosystem as they grow up. T-Rex is a pretty common example because the young ones are really skinny and really fast, while the adults are really chunky and really slow. So they were probably hunting different things. And that's a common thing we see in dinosaurs. If you're smaller, you're going to eat different things than the adults if the adults aren't feeding you. But as far as I know, we never see this degree of ontogenetic niche partitioning. We don't know why they did it.
No journals, no journals or diaries left behind.
Unfortunately not. But we know what this animal is as a juvie. We know what it is as an adult. This is the animal. For a more typical noasaurid, then, we're going to go over to the carnivorous branch. Because a lot of the elaphrosaureans appear to be herbivores, but a lot of the noasaureans appear to be carnivores. And one of the most complete and arguably the most well-known is Machikosaurus. And I know that's not how that name looks, but it is not an English word. It is a Malagasy word, the local language in Madagascar. Machikosaurus translates to fierce lizard, and the species name is Knopfleri. Does the name Knopfler mean anything to you, Vandalia?
What? Say that again.
Does the name Knopfler mean anything to you?
Like Doppler?
No. I guess like Doppler, but Knopfler.
No.
Knopfleri is, first it ends in an I, so it's a reference to a person. Knopfleri is in reference to a band member from the band The Dire Straits. Because the excavation team was listening to the Dire Straits while they were digging it up. Kind of like how Lucy, the Australopithecus, is named for the Beatles song. Sometimes paleontologists do this, and I like it. It's fun.
So what song were you listening to when you did your digs?
A lot of different stuff, actually. I listen to a lot of different things. A lot of Sabaton.
So feature dinosaur name Sabaton.
That sounds like it could be a dinosaur name. It would have to have a really punny species name. Anyway, Machikosaurus. So you'll also notice during this presentation, I've added a little subtitle to every dino. Lemusaurus is a mystery wrapped in an enigma because it's so weird. Machikosaurus is armed to the teeth with teeth. Because this is just what its jaws look like. Unlike any other dinosaur that I know of, Machikosaurus has teeth that project straight out from its dentary and possibly also from its premaxilla. I'm not sure which of these reconstructions is more accurate to the upper jaw, but that's just what the lower jaw looks like. And not only do some of its teeth point forward and some point normally, like a normal dinosaur, the teeth are different in different parts of its jaw. The teeth towards the front of the mouth are fairly straight, and the serrations are really small. The teeth farther back are recurved, so they curve towards the throat, and they're sharper with their serrations. Why does it do that? Why does it do that?
I do not know.
Now, like with Lemusaurus before, this appears to be an exaggerated version of something that is common in other dinosaurs. Except instead of ontogenetic niche partitioning, this thing just decided to have differently shaped teeth. You could call this guy Dimetrodon. You actually could. It has heterodont dentition, which is not a common thing in dinosaurs. Heterodont just means you have different kinds of teeth, like how
Well,
humans have incisors, canines,
well,
premolars, and molars.
well, we could be wrong, but I don't think it's a common thing in most diapsids.
Off the top of my head, I'd say you're right. Now, obviously, there are exceptions, and actually, Nessie in the chat brought up another dinosaur exception. Pachycephalosaurs are heterodont, but theropods usually aren't. And when you have an animal that has heterodont dentition, it's going to have that for a reason. There was a selective pressure to have that evolve.
What?
And
Are you saying selection pressure is direct? Not say direct, but I'm not saying the right words.
Selection pressures pressure things to evolve in certain ways. Yeah, I think that's what you were trying to say. Now, when you do have heterodonty, which is just a shorthand for heterodont dentition, you're doing different things with different parts of your mouth. Using humans as an example, you chop off bits of food with your incisors or break into stuff with your canines and premolars, and then you mash it up with your molars. You're doing different things with different parts of your mouth. You wouldn't typically bite off a piece of something with your molars unless you're eating like nuts or something hard. Or you have weak incisors, which happens. So what was it doing with the different parts of its mouth? Well, some researchers have suggested that it could have been a fish eater. Kind of like Spinosaurs that we'll see later, except it might have had a different method of hunting. The way its teeth are arranged kind of suggests it would pick or snap at something and then retract its head to yank it back farther in the mouth so it could get it with those recurved teeth and hold it in its mouth. So it was probably hunting after really small things, just going like, think of like how a chicken eats. It just darts its head in, nabs, and then yanks it back. Now, if you paid attention to National Geographic when you were a kid, well, if you're my age when you were a kid, if you paid attention to National Geographic in the mid-2000s, you might have seen a special article called Bizarre Dinosaurs. And, well, Machikosaurus was featured there. That's where this reconstruction is from. But at least currently, we kind of think that dinosaurs had lips. So a more modern reconstruction would be more like this from Prehistoric Planet. And if you watch that program, you'll see their Machikosaurus hunting in the same way I just described. They show it hunting little crabs. It just picks them up and then chomps them down. So was it hunting crabs? Was it hunting fish? Why not both? But probably something pretty small. And that's the Noasaurs. This is why I say, or this is why I said at the start that ceratosaurs are just theropods in a microcosm. Because they have one branch that goes off and becomes herbivores. Their sister branch are bizarre carnivores. And then the rest also do weird things. They do all of the weird things that other dinosaur groups do, but they do it within a single, possibly, family. It's, as far as I can think of, they are the only theropod group to show this much variety, except for birds. And birds have had an extra 66 million years to evolve those different groups, those different traits. Also, I just need to type something super quick. Okay. I might have a friend coming in soon. We will have to see. Sorry, moving tabs around. But yeah, that's Machikosaurus. Those are the Noasaurs. Now for something a little more conventional. Ceratosaurus, or Ceratosaurus, or you could pronounce it Keratosaurus if you're a real sticker for Latin. But Ceratosaurus, a nasally dino. It's full, well, there are a few species, but the type species, so the original one, is Ceratosaurus nasicornis. Its name translates to the crested lizard with a nose horn. So nasicornis, nasal, cornis, horn. And go figure, it has a horn on its nose, or a crest. It really is more of a crest. It's thin and wedge-shaped. A horn would be cone-shaped. But Ceratosaurus is from the Morrison Formation in North America, a formation that is really weirdly rich in theropods. Going back a few pages, and I will be doing this a few times, forgive me, folks. All of these are Morrison theropods. And with the exception of the biggest one here, maybe, they're all distinct species. Not counting the biggest one, that's 7 species of theropod. And actually, could be 9. Well, actually, sorry, 8 species because there are 2 different species of Allosaurus, and there might be 2 different species of Ceratosaurus in the Morrison. There's a lot. So Ceratosaurus had to stand out in some way. And how did it do that? Well, it got a nose crest, which, as far as we know, nothing else in the Morrison has. And again, that's as far as we know. And it has disproportionately huge teeth. This seems to be a feature of Ceratosaurus and its closest relatives. And you'll notice there wasn't a specific shout out for the Ceratosaurs like there was for the Noasaurs. That's just because the only good representation we have of this group is Ceratosaurus. There are fragments of relatives from Europe, from Africa, possibly from Asia, but nothing near complete. And if you look down here, these are 2 skull replicas. These are life-size, so the one on the left is Ceratosaurus, and the one on the right is Allosaurus. And you can see that despite the Allosaurus head being much larger than the Ceratosaurus, and there are bigger Allosaurus skulls than this, the largest teeth of the Allosaurus aren't much bigger than the smallest teeth of the Ceratosaurus. It's bizarre. It has these huge teeth. We don't know why. Could they be for prey capture? Was it also going after small things? It'd be kind of weird. It has a really stocky build. It's really it's a powerfully built animal. It has a lot of muscle. It especially has a really fairly thick tail for its size. And that's notable because in dinosaurs, the main muscle pulling the leg back is actually attached to the tail. It usually goes up to about here on most dinosaurs. So it had really powerful tail, would have had really strong legs.
So,
and we just don't know what it was hunting.
So what's the teeth difference between the 2 ones on the top?
What was that?
You compare the teeth of the 2 things on the bottom, but the teeth of the 2 things on the top picture.
Well, I think Ceratosaurus had bigger teeth than a human, just by a little bit. I found fragments of what might be Ceratosaurus teeth, and even just those fragments are this long. It's about as thick as my jaw. Oh, and let's see. I see Caden is pointing out some appearances for Ceratosaurus. When Dinosaurs Roamed America is actually a really good Ceratosaurus. I really like that one. Oh. Jurassic Fight Club has a Jurassic Fight Club is weird because they make it too leggy, which they also do for a relative of Ceratosaurus we'll see later.
Oh, that reminds me.
Uh,
Speaking of
Go ahead.
that reminds me. Were these guys Gondwana Gondwana or Urasaurus?
Uh, so
Laurasia.
Gondwana or Laurasia. They
Yeah.
were Laurasian.
Okay.
I don't think we have any. Yeah, we don't have. Ceratosaurus is known from Western North America and maybe Portugal. And its relatives are all Northern Hemisphere, as far as I know. And let's see. I see, excuse me, Theo's asking, did Allosaurus develop, I'm guessing, evolve after Ceratosaurus? Allosaurus and Ceratosaurus evolved at around the same time. They're found in the same formation. Ceratosaurs broadly appear before Allosaurs do. Allosaurs appear later. But keep in mind that the fossil record is very incomplete. That said, I would be surprised if Allosaurs evolved first, considering Ceratosaurs are more basal. So they're farther down the tree. Sorry, were you going to say something, Vandalia?
I said gasp. The record was incomplete. I'm like, gasp.
You have no idea. With the exception of some weirdly productive sites, the fossil record is awful, frankly, for the most part. Anyway, I mentioned that this thing had a really thick tail. It's not just a thick tail, it's also a deep tail. The spines coming off of the vertebrae, up and down, are actually pretty long. So some people have proposed it could be semi-aquatic, maybe distinguishing itself from the other theropods in its formation by hunting like along streams or in marshes. We just don't have enough data to say for sure. We would need more skeletons, and we'd need to find them like how do I say this? We need to find them in those environments consistently to say that for certain, and at this point, we really can't. With that said, we don't have a lot of Ceratosaurus, which could imply that they were living in environments that aren't good for fossilization.
Like how we don't
Could
have,
and
like we don't have the good fossils for our chimp cousins because they live in the forests.
Or pachycephalosaurs, which could have lived in the mountains. Now, that said, as Nessie actually said in the chat earlier, absence of evidence is not evidence of absence. We could just be getting really unlucky, and who knows, maybe someone will find a huge Ceratosaurus fossil trove someday.
Get on that, people.
Hey, I'm working on it, okay? There's a lot of rock, and there's one of me. But yeah, Ceratosaurus. It's a neat dinosaur. It was mentioned before that it was shown in Jurassic Park 3. It was way too big. Way too big, and the head is really weird, actually. Specifically, the head is way too thick in Jurassic Park 3. Which is kind of shown really well by its relative in this little art piece here, which obviously humans didn't live with dinosaurs, but I like the art too much to not include it. And it illustrates just how skinny these guys' heads were. With a couple notable exceptions, theropod skulls are really skinny. Like, they are weirdly skinny, at least for us. But that's mostly because most of the predators we know of are things like mammals, like a cat or a dog or a bear, or, well, the living reptiles we have. A lot of alligators and lizards have really broad heads. That's how they're constructed. It just so happens those are the main predators we deal with, so we think of predators as having broad faces. Dinosaurs don't. It also really doesn't help that most of the time when you see a dinosaur, you see it from the side, because that's how people like to illustrate them, because then you can see the teeth and the crests and all that. With that said, with that out of the way, our last group within the ceratosaurs more broadly are the abelisaurs. And again, if I gave this presentation last year, I would have said abelisaurids, but that seems to be contentious, so abelisaurs. Abelisaurs include the largest members of the ceratosaurs and a lot of the weirder members of the ceratosaurs. None as weird as Lemusaurus, but still odd. And all of them share a certain batch of traits. They are almost all very tall skulled, so the skull is very high from top to bottom. With small teeth, they have much smaller teeth for the size of their skull, they have smaller teeth than Allosaurus here, which is smaller than Ceratosaurus, so they're different from Ceratosaurus in that aspect. They also have very short legs. Well, at least most of them. If most of them have really short legs, probably, maybe all of them. And they're very long in the body. So they're short, but long, at least for the most part, with possibly an exception. Possibly. I'll get into that when we get to it. Oh, and theoretically says the abelisaurids look like Carnotaurus. That's because Carnotaurus is an abelisaur.
Or is it the other way around? Is it that way or the other way around?
Carnotaurus is itself an abelisaur.
Okay.
Like, a collie is a dog. Carnotaurus is an abelisaur.
Okay.
Abelisaurs are only known from the Cretaceous, at least definitively. There might be some fragmentary remains from the Jurassic, or there might be some in the Jurassic, and we would expect them to be in the Jurassic. But all we found so far are really fragmentary remains that could be an abelisaur. So we need more bones to figure that out for sure. And almost all of them are known from the southern continents. There are a couple abelisaurs, weirdly enough, from France. But otherwise, all of them are from the southern continents. And I don't just mean southern France. There are a couple from southern France. There's one that's all the way up at the top, looking at the English Channel. It's weird.
When you mean southern continents, you still mean the races?
Gondwana.
Oh, southern continent.
So South America, I think we have some. Yeah, Africa. We have some from Africa. And Australia. We also have some from India. And you might say, oh, hey, India's in Asia. That's a northern continent. India was originally attached to Antarctica and Africa.
Yeah.
It only really hit Asia starting in the late Cretaceous / Cenozoic.
I thought it hit Asia way later than that.
Yeah, I think you're right. It is just in the Cenozoic. And it's still hitting the Asian continent, actually. We would expect them to be in... we would expect them to be in Antarctica too. I don't think we found them there yet, but I will not be surprised if one turns up. Like I said in a previous stream about Allosauroids, Carcharodontosaurs, I said it was weird we don't have any from Australia. We do now. That news came out after we did that stream, so it's already outdated. It's not even a month old. And that also really shows just, stuff in this field changes. But yeah, mostly southern continents, some from France, maybe some teeth attributable to them from Portugal. And over here on the right, well, first we have probably the most iconic Abelisaur, Carnotaurus. This is about life size, actually, chasing after this person on a horse. Carnotaurus is one of the larger Abelisaurids. Not the largest, as far as we know. We have one fragmentary Abelosaurid. Well, actually, we have two fragmentary Abelisaurids. One from South America, one from Africa. And both of them appear to be at least 30 feet long, possibly bigger, possibly up to T-Rex sized. But most of them are smaller than that. Most of them are around 20, maybe 25 feet long. But keep in mind, they're very long, but they're short. When we have full legs preserved, they have very disproportionately short legs compared to other theropods. And I'll have a slide later really highlighting that. Now, while Carnotaurus might be the most well-known Abelisaur, it's not the most well-studied. That honor goes to Majungasaurus, who I very lovingly refer to as the killer sausage. Because it is very long, but very short, and it would have been very sausage-shaped in life. And it's incredibly well documented. Its full name is Majungasaurus crenatissimus, so that's a very long name. Majunga refers to the Mahajanga Basin, an area in Madagascar it was found. Saurus, lizard. Actually, fun fact, Majungasaurus lived alongside Machikosaurus. They're found in the same formation. Crenatissimus means, you can translate it as crumpled or wrinkled, and it refers to the teeth because the teeth have very prominent ridges running along the length of the teeth. In fact, Majungasaurus was first identified by its teeth. The skeletons were found much later. There was a part of the top of the skull that were found, but that was described as a different animal, which you might have also heard of if you like dinosaurs. That skull fragment was called Majunga tholus because it was found in Mahajanga, and then tholus, meaning head or skull, because they thought it was a pachycephalosaur, because it's really thick and really robust. This thing had a really tough head, like bizarrely reinforced head. So they thought it was a pachycephalosaur until we found an entire skull and realized, oh no, it's just like that. It's just like that. Anyway, we have 3 partial skeletons that are really well preserved, and between all 3 of them, we have basically the entire skeleton. So we have a really good picture of what Majungasaurus looked like. And the specific rock formation it's known from, the Me Verano, is known for having bizarrely good preservation. So the bones are really well preserved internally on a microscopic level. On the surface, they have great surface detail for like muscle scars and venation. So we know a ton about this animal, both inside and out. This is arguably one of the best known theropods, skeletally speaking. Yeah, it's really cool. And that completeness lets us know that its proportions are accurate. So here's a reconstruction of what Majungasaurus would have looked like in life. Now, obviously, the color is speculative, but I mean, this really is just what the animal would have looked like. We know how much muscle it would have had on the different parts of its body because of how well the bones are preserved. And also, I just want to really shout out this paleo artist. I use his work in every one of these streams. These are pieces by Gabriel Ugueto, and I hope I'm saying his last name right. He does super accurate reconstructions, and I really like his work. So I put together a little compilation here. All of the dinosaurs that you're going to see on this slide are, well, first done by Gabriel Ugueto, so same artist. They're all in the same pose, and they're scaled from nose to tail to be the same as the first picture of Majungasaurus. So in real life, Majungasaurus is about 20 feet long. T-Rex here is about 40 feet long, but they're scaled the same nose to tail, just so you can see how weird Majungasaurus's proportions are. Also, I'm seeing in the chat, Nessie, if you'd like to join us, please feel free. You're more than welcome. You should have the link. If you can't figure out your microphone, you can just use your computers. It won't be fabulous, but we'll be able to hear you. So if you want to join, feel free to join. Anyway, so for some comparisons, and just so everyone knows, Majungasaurus is about 20 feet long. It is about 4.5 feet tall at the hip. Your old hunched grandmother is taller than this dinosaur, at least at the hip. T-Rex here is 40 feet long and about 13 feet tall at the hip. This is Allosaurus. Allosaurus was on average about 27, 28 feet long and 7 to 9 feet tall at the hip.
Looks like these guys had small arms too.
Yeah, we'll get to that. And here is a theropod we have already seen in this stream. This is Ceratosaurus from earlier. Ceratosaurus is about the same length as Majungasaurus, but it's about 5 to 6 feet tall at the hip. So, like, you can see how tiny these legs are. And Vandalia, you're skipping ahead because you mentioned the arms. Abelisaurids, relative to all other theropods, have the smallest arms compared to the size of their body. They are minuscule. And it's a trait this entire group shares. We do not have an Abelisaur with functional arms.
You thought T-Rex was bad. There's nothing.
No, T-Rex is one of those guys. It is like one of those 300-pound bodybuilders on a beach in California. Compared to Abelisaurus. Also, it sounds like Nessie is here, Vandalia. She's asking if you could add her.
So she pops in. I don't see her in the.
Okay. So Nessie, if you want to join, just click the link that's in Discord, the restream.io one. If you just click that one, you'll be able to join right in the room. Up to you if you want to stream this to your channel then or not. Yeah, just click the link. It'll bring you into the lobby, and you can join us. And I know you like Majungasaurus. and I'd love to pick your brain about the ontogeny of Lemusaurus too, actually. But while we wait, I do have a bit more to share about Majungasaurus. So Majungasaurus continued. What do its bones say? As I already teased, the skeleton for Majungasaurus is so absurdly well preserved. We know a ton about its physiology, both inside and out. For starters, as already mentioned, all abelisaurs have super reduced forearms. Well, just arms, I guess I should say. Their digits, so fingers, their radius and ulna, so the forearm here, turn into tiny nubs. This Oh, and so Nessie Vandalia just reposted the restream link if you want to join. This is the arm of Majungasaurus right here, zoomed in. These are not wrist bones. That's the forearm. In several abelisaurs, the fingers are longer than the forearm. I don't think there's another, at least land vertebrate, that does that. Unless, well, maybe some amphibians, because they're weird, but very little else does that. They're super reduced. The muscle attachments on the arm, just as a whole, are really, really tiny. If they could move them, which they could move them, they would have been really, really weak.
Hello.
Hello, Nessie. Can you hear us? Oh. Let's see. Nessie, you might have to go into settings. We're not hearing anything from you. If you're trying to use your microphone, make sure you have the input device set. Hopefully she figures that out soon. Anyway, they could move these arms. The shoulder joint is actually really, really mobile. Like weirdly mobile for a theropod. And if you've seen Prehistoric Planet, that's what appears to have inspired that scene where they show the Carnotaurus wagging its arms around, which I just think is really fun. It's a great little segment, to be honest. Weirdly enough, the shoulder of abelisaurs, just in general, in contrast to the arm, becomes huge. You can see it on the body. We're hearing something. I'm hearing myself.
I think I'm doing it.
Yeah, I can hear ya.
Thanks, Vandalia. I appreciate your support.
How's it going, Nessie? How was the drive?
Oh, it's terrible, but thanks. I think my video is catching up.
Not seeing any video, but
voice is all that really matters at this point. So anything you want to add to what we've already talked about?
Well, Majungasaurus she's baby.
Yeah, I know Majungasaurus is one of your favorite dinosaurs.
Oh,
not
yeah.
the favorite, obviously.
Why? Why is Majunga one of my favorites?
Because it's the killer sausage.
Because it did marijuana.
Oh gosh, I mean, I don't know.
Oh. I mean, I know there's been some fabulous osteology done on it.
I enabled my camera. I don't understand why it's not working.
It's all right. It's okay.
No, it's not okay. Oh, did I do it?
Oh,
yes.
Yeah, there you are.
Okay, cool. And I got my... Oh, why am I so far over? Oh, this thing on the bobber.
There you go.
Yeah, no, I've been listening the whole time, and I'm over here like Lunosaurus, Majungasaurus, Abelisaurus, yeah.
I mean, they're bizarre, they're weird, but they're great, and they're just so lovable. I don't know.
Well, face only a mother could love. I'm the mother. You're the mother. I agree.
All right. Well, let's see. Where were we? Oh yeah, Majungasaurus bones. Weird. Arm gets tiny, scapula gets huge. Why is that? Well, the scapula, in vertebrates at least, land vertebrates, land vertebrates, is a really important muscle attachment site. You have a ton of muscles from your chest and your neck and your arms that all go into the scapula. Well, I'm pointing up here. It's on our back because we're apes and we're weird. But on Majungasaurus, it's up here. So your bones change according to what you're doing with them and what you need them to do. So for some reason, Abelisaurs needed really powerful muscles in the chest, connecting the torso and the neck. And at least according to some authors, and I tend to agree with them, they were probably doing something weird with that head when they were hunting.
Are you talking about Thomas Carr, Tom Holtz?
Do they have that opinion?
Oh, Tom Holtz did. I was just wondering if you knew about Tom Carr's opinion.
I don't know what his opinion is. But
Dinosaurs
I mean-
don't have lips. That's the only opinion I know a lot of his opinions because he came and worked with us at MOR a lot. But I was just wondering if he had any opinions on Majunga. Because he came in, we worked together on the Despledosaurus. That's up at Museum of the Rockies. But I don't think I really heard anything about a Majunga.
Yeah, I haven't heard anything either. I'd be curious what his opinion is, since, I mean, he loves Tyrannosaurus so much, and they also get the tiny arms.
Right.
But I know they get a long scapula. They don't get a super robust one like the Abelisaurs do, right?
Yeah, it is strangely like long this way. But it's not thick like you would think. And most like tyrannosaurs
Yeah.
and other animals that had bigger scapula. But it's thin, it's long, and the arms attached to it, it just doesn't seem like a very robust animal at all.
Yeah.
Yeah.
So at least according to what I've read, and well, I mean, I agree with them. It seems that of the big groups of theropods, so the groups that get really big and become apex predators, Tyrannosaurus evolved for a strong bite. They evolved to crush bone. Allosaurs evolved to shred with their bites, cause hemorrhaging. It appears that Abelisaurs evolved to grab and shake, or drag their prey around.
Hey,
Like a dog with a bone.
I am hearing I am hearing an echo. Do you have your headphones plugged in?
I only have my microphone.
Okay.
Okay.
Is it me that has the echo?
It is you. It's not that bad.
Okay, it's making sure. Right.
It's not a big deal, but if you can plug in earbuds, it might be better for the audience.
I can turn it all the way down. Sure.
And no, it's picking up the voice coming from your computer. It's feedback.
Oh, okay.
Okay. I don't know if Restream will change the audio output device or not automatically. But I'm not hearing an echo now, so can you hear us in your earbud?
Yeah.
Okay, it did it automatically. That's cool. So yeah, Tyrannosaurus, chomp, Allosaurus, slice, Abelisaur. The way they probably hunted was by wrestling prey to the ground, which that hunting strategy explains the soup. Oh, I didn't mention this. They have super powerful necks. If you look at the neck vertebrae of a Belosaurus here, they have super long cervical ribs, which are extensions of the neck vertebrae for muscle attachments. You can see them in sauropods like Diplodocus or Apatosaurus. When you have big ones, it usually means you have a really strong neck. So, strong neck, strong torso. A hunting strategy like that would explain why they needed to be so robust. And it could also partially explain the short legs. If you have a lower center of gravity, then it's harder for you to fall over. And it's easier for you to pin something else.
It's also hard for you to get back up.
Well, I mean, honestly, it might just mean you don't mind falling over as much. You have less far to fall. And just so everyone knows, these things were hunting sauropods. They weren't just going after
Good. Eat all the
small prey.
sauropods.
In the Maverano Formation, again, this formation with spectacular fossil preservation, we have a lot of titanosaurs that would have been about 40, 50 feet long in life, and their bones are just covered in Majungasaurus bite marks. So they were hunting sauropods. And actually, to illustrate the hunting style I've been talking about, I thought I'd include a couple videos. Because there's actually a really good representation of this hunting style.
Are you gonna play the same videos as Serena having elephants on trampolines?
I mean, I doubt it. These videos are actually from Jurassic World Evolution 2.
Okay.
Well, this game has Majungasaurus hunting in the same style I was just talking about. So here it is. Here it's hunting a Nigerosaurus, which it didn't live with, but Nigerosaurus did live with a Belosaurus.
Run, girl, run!
So,
no!
This is probably actually pretty accurate to how it would have hunted. Wrestled prey to the ground, and then chomp.
Yeah.
And I'll replay it super quick. Bizarrely enough, this game probably has a really accurate hunting strategy for this guy.
Yeah, but if
I think that's kind of cool.
At the same time, then tell us more about the animals that did live in the time.
I can do that.
So this is the guy who would be the new WWE champion then.
Yeah,
in my opinion. Let's see. Well, Majungasaurus lived in the Mahajanga Basin at the end of the Cretaceous. It would have lived with sauropods such as Rapatosaurus. The best skeletons we have for it are juveniles, but we do have bones from adults. And again, this would have been a 40, 50 foot long sauropod. Not gigantic by any means, but still a really big animal. And the adults have bite marks from Majungasaurus.
Hashtag broken jaw.
It also lived alongside Machikosaurus, which we showed off earlier, and I'll just go ahead and show it again. Oh, and actually, Machikosaurus is actually pretty small. It's a pretty small theropod. I don't think I mentioned that.
He's a cutie patootie.
It lived alongside several species.
So, Machikosaurus was, where are they from?
They're from the Maverano Formation in Madagascar.
Okay, because I thought I found some of those back when I was in Niger or Madagascar.
I mean, definitely possible. Were you there with the Field Museum?
Yes.
Well, most of the skeletons we have are from Field Museum expeditions, so I wouldn't be surprised.
Okay.
I've heard their teeth are very
I brought
common.
back a bunch of mosasaur teeth. Don't even get me started on mosasaur teeth.
Well,
Am I still
as for other
echoey,
things,
Vandalia?
Say that
a
again.
little bit, but it's not bad.
Uh,
I don't know
Um,
what I need to do. Should I just unplug my? Maybe if
no,
I unplug my
it's
microphone.
okay. If you unplug your microphone, we're gonna probably not hear you.
Can you still hear
Um,
me?
yeah.
yes,
Is it better or
yes,
worse?
Yeah.
This is better.
actually better.
Yeah.
Yeah.
Weird.
Huh.
Okay, that's a $200 microphone. So here we are. All right, keep going.
Well, for other things it lived with Semasuchus, which is a
Yes, I'm a
herbivorous
Sucus.
land croc. And in
Yeah.
Prehistoric Planet, you get to see a Majungasaurus try to hunt a Simasuchus.
I
It
love
doesn't.
Samasuka so much.
It's really, really cute.
Well, you and I
Um,
have played with a bunch of larger crocs that have been out here. In
yeah,
Wyoming.
but I'd love a pet Semasuchus. They just look so cute.
Okay. What else? What else?
I mean, that's most of the large reptilian fauna. There are large snakes from the Mavorano. There are mammals. Some
Yeah. I'm tired of
not
this.
really early mammals, but weird Cretaceous mammals. And I think there are bits of pterosaur.
Yeah,
And
the two crushed ones. Is that what you're talking about?
I think so.
Mm.
And there's a fragmentary little thing called Rahonavis,
It's
which we're
Rojo.
not sure.
It's Rahonavis. It's
Rahonavis?
Latin for red. Like Spanish is rojo, Latin is rock.
Actually, it isn't. It's named for a local Malagasy deity, basically a god of thunderstorms.
Oh
And
yeah,
then
because it's
Avis.
not a J.
Yeah.
It's with an H, so that would make
So,
it the god. Or
so it
god.
translates to something like bird of the thunder god, which
Yeah,
I think is
bird
fun.
of thunder. That's so cool. Education.
Yeah.
Science.
The more
with that
the
said,
more you know.
That's actually really cool. I didn't know that.
Mhm.
I always thought it was called Rajo Neves, and I never saw the way it was actually spelled. So this is really cool. Thank you so much for educating me on this.
I'm happy I could teach you something.
Wow.
The funny thing about Rahonavis, though, is we're not sure what it is. Now you might look at it and think, "Oh, that's a bird." Is it? Different studies have come to different conclusions.
Do we only have one specimen?
We have one specimen. It's really well preserved, but fragmentary. We're missing.
Okay. Oh yeah, show me the.
So white is what we have.
Dang! Look at those arms, boy.
Yeah, long arms.
Wow.
The weird thing is, it could be a bird, but if it is a bird, it's weird because it's weirdly primitive.
And large.
Or it could be a type of dromaeosaur that convergently evolved flight.
So they don't have the claws? I see that, like little hands, but I don't see that in the preservation of the body.
No, the claws are inferred. Yeah, actually, this is probably the best one. The claws are inferred for the hands, but we know it has these really long hands because we have the radius and ulna, or long arms.
Right.
And that's primitive for birds, especially from the latest Cretaceous. Like, we tend to lose birds tend to trade out the bones for feathers pretty quick.
Right.
So it's either a late surviving weird bird, which is a possibility, or it's a type of dromaeosaur that convergently evolved to fly.
Do you think? And this came before Archaeopteryx, so it's a possibility that certain things converged.
much after Archaeopteryx. This is from 66 million years ago. Archaeopteryx is from 150.
Like one of the most recent ones, then, huh?
Yeah, and
Yeah, and it's this primitive.
And opposite sides of the dino family tree too, right? Nowhere near related.
Well, they would be separated by probably about 160, 170 million years based on our current models. So they're about as far apart as you can get and still be a theropod.
No, it's not a velociraptor.
So
if anything, it would have been a Deinonychus, but it's not.
So kind of
Well,
like
it's
convergent. What convergent evolution?
possibly. We do have another dromaeosaur that did evolve to fly, Microraptor.
Right.
So, but we don't know if Microraptor.
Too big, right? How big? How tall was this?
The scale bar here is 10 centimeters.
Oh, she's just a baby.
So it's like the size of a large crow.
Okay. So we found something in Montana a couple of years ago that we can't describe as an Archaeopteryx, but we can't describe as a Microraptor. But it was another in between, and I wonder if it was something similar to that. Do you know where this one was found?
Madagascar.
All right, we might be looking at a similar timeline. We might be looking at a similar timeline.
I don't know. I mean,
oh, a little hand.
Yeah, there it is compared to a hand. So like the size of a big crow.
Dinosaurs. Me earlier today feeding rice to my crows.
But yeah, this group of dinosaurs, just the Maniraptorans, just seem they're primed to evolve to fly, or at least glide, and it appears they do it at least twice, maybe 3 times, maybe more.
Well, hopefully when you feed this guy rice from your hands, he won't try to eat your hand too.
He could take my pinky and I still love him.
I'd want one as a pet. They do have the raptor killing claw, which birds primitively had and most lost. Archaeopteryx actually has a killing claw, and we just figured that out a couple years ago. Anyway, back to the apex predator of the Mevarono.
Do you want me to get my Majunga off my...
Yeah, you know what? Go ahead. We can compare it to the skeleton, see how accurate it is.
Okay.
So while she's doing that, I'll just explain the photos we have here. This is a composite skeleton, so it's taking all the fossil elements we have, scaling them to the same size, and putting them together. As you can see, we pretty much have the whole animal. This second image is showing pneumaticity in vertebrae. So how airy the vertebrae are, how much space there is. And Majungasaurus, despite being more basal than Allosaurus, actually has more bird-like vertebrae. It has more air spaces. And the stupid arms.
So where are these guys on the feather scale?
We'll get to that with the next animal, actually.
Okay.
Here, can you bring it closer to the camera, Nessie? So Nessie has one of the Jurassic World Majungasaurus toys. And if we compare it to the actual skeleton, well, first off, the arms are too big.
And it doesn't have a thumb.
Yeah, the real one doesn't have a weird thumb. The neck's too short, and so is the body and tail.
Yeah.
And the legs are way too long.
Okay, first of all, this is from Jurassic World, so they're not supposed to be accurate.
You and I both know that's not a valid excuse.
Yes, huh? Okay, then no, I'm not getting into the Jurassic World debate.
I'll not fight you on this again. Not again, Nedry.
Not a kid. He's cute though.
It's cute.
Yeah.
I did want to pick your brain about an earlier topic, Lemusaurus.
Oh
So-
yeah. No, I was watching your Lemosaurus stuff, and I'm over here like.
Okay, go off. What do you have to share about
Okay.
one of the weirdest dinosaurs I've ever seen?
Yeah. So there are teeth that were found with the elder Lemosaurus, but they haven't been described or worked on. So let me just
But
put my hair up in a weird bun.
the adults don't have tooth sockets though; they close up.
But they had. Oh, you talk about all these other dinosaurs that have leaf-shaped teeth and call them herbivores. That's not true. A lot of the leaf-shaped dinosaurs, I think, were, well, I guess that's my own opinion, but working with marsupials, packies, ankies, I think they were omnivorous. I
mean, I wouldn't be surprised for a lot of them, but
well, especially packies. Come on, you see a delicious looking bug, little insect dripping by, and you're
yeah,
get it.
I agree.
Okay, so I think all of these animals that have the leaf shaped teeth, I think the teeth shape was good for stripping ferns,
Yeah,
but I also think they were scrumptious on some insects.
I mean, probably, but so just with Lemusaurus here, the juveniles have like pretty classic theropod teeth. They're sharp, pokey, but the adults
Go back.
like
Sorry.
okay.
Go back one thing.
But like the adults, they don't have tooth sockets. They don't have anywhere for the teeth to go in the jaws.
Oh,
And we found
you mean like
dozens of adults.
elderly, like older Lemosaurus?
No, just adult, not even senescent, just adult. We have dozens of them. This diagram is showing, so it's the maxilla, the premax, and the dentary of a young juvenile, an older juvenile, and full adult.
Okay.
And as they turn into adults, the teeth just drop out and the sockets close up. There's nowhere for teeth to go in the adults.
Has there been any research on like the dietary
yes.
needs of Lemosaurus?
Yes. The juveniles appear to have been carnivorous, and the adults appear to be herbivorous.
That's crazy. Could you imagine going from eating meat to being a vegetarian? I don't know.
Yeah, but we know they're the same species because we have the complete
Right.
we have a complete ontogeny.
Skeletons. I understand you have the composite skeletons. And that's the reason when I popped on, I was like, well, I heard the word ontogeny. Yeah, your girls gotta pop in.
Yeah, they did that in a more recent thing with I think it was iguanodons that became from bug eating to plant eating on an island.
Okay.
Like an iguanodontid that changed diet as it grew up?
No. I mean, it was lizards, modern animals, iguanodons.
Like a literal iguana.
Iguana.
Oh, okay.
They went to a island without bugs.
Yes.
And then they adapted.
Yeah, I know what you're talking about. They did do that.
Sometimes, given the environment you're in, sometimes you got to do what you got to do. So if this happened, then there must have been something that happened for them to cue this in, right?
And just Vandalia, what you're talking about isn't weird. That's a population evolving to change the diet.
I mean,
that's a good thing.
It is. Lemusaurus is weird because it changes diet, in a
Lemursaurus
lifetime.
is just
Like
weird.
each individual does this. This is just the species. All of them do this as they age.
So it went
It's
more from therapeutic to ornithomimic to.
yeah, they're like mini ornithomimids.
Oh, that's so cute. I love it.
Yeah. I mean,
And like an
it's
ostrich, like what's happening to this
yeah.
this
They
poor thing?
I don't know.
Nobody knows
It's
apparently.
I mean, it's
So
obviously onto
the
genetic
younger
niche
ones had
partitioning,
teeth,
but yep,
and the older ones have no dentary at all.
they have a dentary. They don't have teeth and they don't have tooth sockets.
So they have no like battery. The mandibles are just straight up.
Yeah, you can see the
that's-
change here. They thin into a beak, both the top and bottom jaws.
That's the
Just a
fastest.
cropping beak.
That's the fastest evolutionary change you can see in a singular animal. Honestly,
It's not evolutionary. It's ontogeny.
Ontogeny, yes, but that's the fastest that evolution could change a singular animal within ontogeny.
Okay, I see what you're talking about.
That's crazy fast.
And I mean, obviously, it's onto genetic niche partitioning, but
It's very niche. I'll give you that.
I'm pretty sure it's the most extreme case in just vertebrates, just in general. I don't think there's another vertebrate that does
this. Do you have
this.
the paper?
Yes, I do. It's actually linked at the top there. I can send it to you if you want.
Oh yeah, no, I'll find the paper.
If you just search Lemusaurus diet, it's one of the first ones that pop up. But I'll send you the paper.
Diet, okay.
Well, yeah.
This isn't okay for everybody else out there that's listening. This is incredibly interesting because I study ontogeny of Pachycephalosaurus. So you got your Dracorex, your Stygimoloch, and your Pachycephalosaurus going from nothing to a big boy. This one's incredibly interesting because I've not studied this one. And I think this could help me because that means the osteoblasts and the osteoclasts within their face must have also been changing head fast. So
yeah,
thank you.
Yeah, they're really cool.
Yeah,
and I just sent you the paper.
Okay, thank you. I appreciate that.
Yep. All right.
So now that we're over Lumosaurus,
shall we get back to?
Yeah, I love it. Back to Majunga.
The Abelosaurus. Well, I think we did already say about everything I wanted to say on Majungasaurus, but we do have one more Abelisaur to cover.
Which one's that? Oh, well, yeah. I thought that was the whole. Oh no, this is Carnotaur. I thought you were gonna go to Ceratosaur.
No, we already did Ceratosaurus.
Yeah.
So as with all of the previous ones, this one has a subtitle: Carnotaurus, the odd one out? Question mark? See, among Abelisaurs, this group that's characterized by their stumpy little legs, there is one member that's often shown to be a really long-legged and really fast hunter: Carnotaurus sastri. And as with the others, I'll break down the name. Carnotaurus means meat bull, usually translated as meat-eating bull. That name is in reference to the two horns it has on its head. Sastre is after a person. So it is Sastre's meat-eating bull. And a lot of different kinds of media show it as a natural sprinter. But was it really? Well, similarly to Majungasaurus, we do have a lot of the skeleton. But for this particular puzzle, we're missing a very important piece. Its legs. After a person. We have its upper legs, and we have the tops of its tibia. We have nothing below that. So why do we think it could have been a really fast runner when everyone else in its family isn't? Well, I mentioned before that dinosaurs had a lot of muscles in the tail. Those powered the legs to help them run. In Carnotaurus, we do have the base of the tail. And the muscle attachment points there are really huge. Like they're bizarrely massive for a theropod dinosaur. So we know it had super strong legs, but we don't know what they were doing with them. Was it running really fast? Maybe. We can't say. Or was it doing the thing we talked about with Majungasaurus, where it was wrestling prey to the ground, so it needed strong legs? At this point, we don't know. I hope we find out someday. I hope we find another Carnotaurus, but at this point, I can't tell you. Was it the odd Abelisaur that could run? Or was it a little sausage too?
Little sausage.
Yeah. And just as an aside, it has some really cool horns. It's a really cool animal, regardless if it was a fast runner or not. But yeah, we just don't know. And Vandalia, earlier you asked about where ceratosaurs were on feathers. Well, we actually have really great skin impressions from Carnotaurus. We have them on every part of the body that was preserved. It appears we had them on the head, but preparators didn't realize what they were at the time, so they destroyed them on accident. And Carnotaurus does not have feathers.
Yeah,
It
didn't
has...
they think they thought it was grass? They're quills, though, right?
No, it doesn't. It has no feather-like structures. It just has scales. It seems to be...
No, I mean what the preparers thought. It wasn't feathers, but they thought it was quills. And
No, they
went
didn't
through all the
recognize that they were
testing.
skin impressions.
But there were certain things that they went through testing and found out that it was grass.
Oh,
At
I
least
mean,
that's what my
definitely could
friends
be. I
thought.
haven't heard of that before, but I wouldn't be surprised.
Oh, okay. Well, they're my friends, and that's what I heard. So,
Well, that explains why you know it.
jeez.
What it does have instead of feathers is actually a pattern that's very similar to ceratopsian scales.
That's true.
They have lots of tiny scales with
Mhm.
random huge ones scattered around. So
And
from a
don't
distance, it would
they
look really
also have osteoderms?
Yes, they
They
do.
have those
They also
large,
have osteoderms.
and
But
that's so cool
yeah.
to me because I'm the
Mhm.
queen of osteoderms. So as soon as I saw that, I was like, "Let's go!"
Yeah. And a lot of older reconstructions of Carnotaurus will show the osteoderms in neat lines around its flanks. It appears they were more randomly spaced, so it just had random patches of armor covering its
Which is
torso
so
and tail.
weird. Could you imagine, like, an ankylosaur, just like instead of having straight armor, it was just like, well, here and there.
Yeah, it's just
It was
randomly
kind of
put
like
together.
that. They were
It's
randomly
bizarre.
patched.
Yeah, and it's a weird animal, but it's a really cool animal. And
That's cool.
it is my second favorite dinosaur, actually. Not
Majunga
my first, but my second.
or Carno?
Carnotaurus.
Carno, okay.
Hmm?
After we watched Disney's Dinosaur together,
Well, that
stand
movie is part of
together.
why that movie is part of why it was originally my favorite dinosaur.
Yeah, well, I get
Well,
it.
that and a few other pieces of media.
Watching Dinosaurs, Fight Club, so many.
Well, it wasn't in Jurassic Fight Club. Majungasaurus
No,
was
I
in
was just
Jurassic Fight Club.
saying those are the pieces of media that helped
Sure.
develop your love for the dinosaurs as much as mine.
What dinosaur was in the Chef Boyardee dinosaur pasta?
I don't know.
Oh my God. There were three. There was the Stego, a sauropod, and a T-Rex. And I'm proud to know that because I ate it a lot being poor growing up.
How about the Dino SpaghettiOs?
I thought that's what I was talking about because that is Chef Boyardee.
I didn't know they were the same brand. But with that,
And on
thank
that,
you to everyone who has been watching or listening.
oh, I like that picture. No, run, little boy, run.
All right.
Yeah, this was
All right.
this was a redesign they were considering for the Ark sequel, but I think they just kept the old Carno, which I'm kind of sad about. I like this one a lot.
All right. Now, time for if you have questions. Now's your time.
And
Question-
also, Caden, stop apologizing to me. I'll deal with you.
Caden,
you.
we've told you before, you're fine and you're fine to
Yeah,
ask
you're
questions.
fine.
You-
We're
no need to
simple
apologize.
Folk. We're simple folk. My hair's still wet, so I got out of the shower. As soon as I got home, I hopped on to help with the Carno. Don't know if I helped much, but
You contributed.
I like to think so.
So yeah, if anyone would like to ask questions about any of the dinosaurs we've talked about today, any others you're curious about, I can probably answer quite a few of them. Nessie can probably answer a ton.
How
She's
many
just done a
people
lot
do
of
we
work
have
on
in
paleo
here?
in general.
All right.
How many
First
people-
question: How was your field trip? Not dinosaurs.
Well, I didn't find the MOR library. She's dug in there somewhere deep.
Yeah,
So it wasn't very fruitful.
was it a pretty drive at least?
It was alright. Pretty gray. Nice and
Yeah,
warm
fair.
today.
Okay.
Yeah, it's supposed to get into the 60s soon.
Yeah, it was like 57 today. And the Alaskan seafood guys were closed today, so I couldn't get more crab.
No,
And you know how much I love my seafood boils.
I know.
We have our first question.
Okay. What would the actual color be? So the unfortunate thing is, for most dinosaurs, we will never know. There
So
are some we do know.
We do know there are some feathers trapped in amber that are a pretty stark red color. But other than that, we don't know. I like to think, and this is just all a hypothesis, that they are similar to birds today. So I think that the males would be more prominent in color. And boy, you better dance. I like
Do the prehistoric planet dance.
planet dance. No, but
I mean,
right now we only have skin impressions, and closest thing we have to knowing the colors is the red color we have trapped in amber.
Not just that. There's also Borealopelta.
Oh yeah. Ugh.
Oh, you love that one.
I must scream. Oh no, that's
It's Sauropelta. Borealopelta gets a pass.
Fine.
We know what color Archaeopteryx was. It would have been actually colored like a raven. We know what color Sinosauropteryx was, which is or a magpie. Sinosauropteryx was like a fluffy little red panda. It's a little tiny carnivorous dinosaur.
No.
No, we do.
Because you have no evidence that anything was white.
We
There's
have
no evidence of anything being white.
We have evidence for the absence of
The absence
pigments.
of color. Okay. All right.
We have, I mean, we have feathers from all over Sinosauropteryx's body, and we know the pattern of the melanosomes.
It was
And-
just been buried for over 65 million years.
Yeah, but they're there.
The absence of color.
I mean, it could have had structural colors, but we know it at least had red, and it had a little bandit mask.
Yeah, that's what I'm saying. I don't think it was white.
We got a $20 super chat.
Oh yeah. Thank you, Vamsy, Jessica,
Thank
Amanda.
You, Vamsy. Hi, Jessica.
No message attached to that. If you have a question or just have something you want to say, feel free to put it in the chat and we'll highlight it. Thank you.
Meanwhile, a question back there: could they roar at all?
Probably not like in Jurassic Park. If you want to hear what dinosaurs probably sounded like, your best bet would be the program we've mentioned a few times now, Prehistoric Planet. The way they have the dinosaurs vocalize in that is basically how we think they vocalized. It's based on really recent evidence.
And I've seen some TikTok videos where they lower it. But y'all, everyone in chat, okay, if y'all want to see something scary, watch the YouTube, might be on TikTok too, of the re-edit of Dinosaurs with Feathers.
Yes.
It's terrifying. And I think, honestly, I think Dinosaurs with Feathers are scarier.
Yeah. So for context, there is someone on YouTube who reanimated some of the scenes from Jurassic Park with raptors and animated in accurate Deinonychus, like with feathering, and it's stunning. It's actually movie quality CGI.
I want to. I like to see if they did the Velociraptors actual sizes, if they would have been as scary or less scary than the ones they had on the movie.
No, I'm more. It's the same scene, Vendel.
Yeah.
It's the same scene, but they put feathers on them.
Vendali is asking if the scenes would be as scary if the Velociraptors were the size of Velociraptors.
Oh, like Deinonychus?
No, well, specifically Velociraptor, I'd say probably not. If it's the size of Deinonychus,
scared of those little punks too.
I mean, I wouldn't fight them. It'd be like trying to fight a bobcat. You're not going to come out of it unscathed.
Compies ate Cooper, so what would I do with this one? This one's only this one's about the size of me. I'm only 4'10", so a raptor would only be like up to here to me. So yeah, they would still be scary to me.
Well, I mean, Deinonychus would be taller than you, at least based on the largest specimens.
Yeah, I know. I built them.
I know.
But putting feathers on them is absolutely terrifying.
Mm-hmm. You know, I'm
scared.
I don't want to play it.
What are you talking about?
I'm not going to play the video because I want to encourage people to go watch it. But I'll show a still from it just so people can see what we're talking about.
Oh, play it. Do the headpiece.
All right. So this is by Coolio Art on YouTube and possibly other places.
You made it.
Here, if my internet would cooperate, we'll give people a little taste, but highly encourage you to watch the full thing.
This one. Oh.
Uh-huh. Oh, that eye.
Oh, it's even better. Dude, it's even better.
Yeah, than Jurassic Park. Aaron, scene of them talking. Kids are safe unless they can open doors. For some reason, my internet's being slow. Come on. Yeah, I'm sorry. My internet is being awful right now, and I have no idea why. It's usually much better.
While we're waiting for the internet to work, any more questions out in
Here,
the
let me turn
out
off
there?
my camera. Maybe that'll free up some bandwidth.
The ginger.
I mean, you're not wrong.
We are looking for questions.
It's funny. Dinosaurs with and brothers.
Reload the
Okay.
page. Will that do anything?
So I went. Oh well, if this plays, I'm.
Come on. Internet, would you please not for 5 minutes? Is my voice breaking up?
No.
No,
Or is
your
that
voice
coming through okay?
fine. No, she's not.
Okay. Maybe it's just YouTube. Maybe YouTube is just being a butt right now.
Yeah.
Oh, why don't you think
Anyway.
dinosaurs could open doors? Why don't you think they could figure that out? Like
I mean-
cats. My cat can open my door.
Yeah.
I
Anyway,
think they could figure it out. Plus, crows are really smart, and if their
Mhm.
paws are similar to that, then why not? Just a question.
I mean, I'd be surprised if especially a dromaeosaur couldn't open doors. But
I
anyway,
think they could.
the channel that uploaded this is called
I mean-
Coolio Art. Highly recommend checking this out to everyone watching. It is spectacular.
No, I
This-
don't. I know it's a Deinonychus. I'm sorry, Theo. Did you ever work on a Deinonychus? Because
yeah.
Deinonychus is still kind of small, but I think it's closer to a Utahraptor or a Dakota Raptor. And the
Okay,
movie-
now the video is playing, but it's frozen. Yeah, I think YouTube is just not acting correctly right now.
Oh, hi, Georgie.
Hi, Georgie.
I got your picture still in my.
Here.
Well,
Um,
let your
so-
brother tell you.
it's all right. As for Theoretically's comment, though, size is never Deinonychus, must be Utahraptor or something larger.
I have your picture.
So the thing is,
in
the raptors in Jurassic Park are within the theoretical size range for a Deinonychus. Like, theoretically,
yeah, but they're
Deinonychus could
still
get that
a
big.
little too big.
Yeah. They're too big for known specimens, but
I
not
think
terribly
they're
much.
Raptors or Dakota Raptors.
But they're found in well, I mean, they are found in Montana. Maybe a Dakota Raptor, but yeah. How many specimens of Deinonychus do we have? Well, as of last year, we have at least one more, because I found one.
That's true.
I
But
think we have at least 5 or 6 partial skeletons.
No, there's 11.
Well, I did say at least.
At least. But hi, Georgie. Thanks for
All
being
right,
a little
well.
your girl that I wish I could hold.
Oh. Well, unless there are any other
3
questions,
meters long,
I
but
think
yeah, they're not that tall. They're not as big. But when Michael Crichton was writing the book, he thought Velociraptor sounded cooler.
because he was relying on Greg Paul's book.
All right.
Yeah.
So, advertisement. What's gonna be up on your channels? You want to advertise?
Well, I'm working on a few things right now. I'm working on some shorter videos that I want to get out soon, and a longer video about crocodilians and how different groups of animals keep evolving into crocodilians.
Kind of like crabs, but crocodiles.
Yes, exactly like that. Actually, it's just this bizarre thing with all kinds of vertebrates. They evolve the same shape, the same hunting strategy.
Yeah, you're right.
Every major group of vertebrates has a crocodile representative. Everyone. Even mammals. Whales went through a stage where they were basically warm-blooded crocodiles.
they went through a stage where they look like puppy dogs
Yeah, that too. With hooves.
with hooves.
They went through they went through a stage where they were no, I'm talking about like crocodiles now. They went through a stage that they were bipeds. Crocodiles did.
Yeah, there were bipedal pseudotsuchians. Yeah, they weren't the crocodile line, but yeah, there were bipedal crocs. Oh, actually,
like Postosuchus,
yeah,
Pseudotsuchus,
I,
Postosuchus possibly.
yeah,
Well,
Postosuchus, poposaurs.
that's what
there,
we said it at the same time. High five.
yeah. Actually, Nessie, I just recently heard about, and I haven't found the paper on it yet, but I heard that there is a croc trackway from the end of the Cretaceous that shows a bipedal croc. Like
Over
it's
here.
I don't know where. I just heard that it exists, but it's a bipedal crocodilian trackway from the end of the Cretaceous. So apparently they were still around at the end. Here, maybe I can find it. Do you have anything you want to shout out for your channel while I look?
Me now.
For me, after this stream, I will be streaming over my Twitch channel as I learn how to be a warrior.
A warrior?
Yes.
And what are you doing? You shooting bow?
Bows, swords, shields. I'm usually a magic wielder, but now I'm going to be hitting things.
Okay. You know what?
It's always fun.
Heck yeah.
Here, Vandalia, I'm going to share my screen super quick. I found the paper. And it wasn't the latest Cretaceous, but it's from the Aptian. So that's what, like 100 million years ago? Bipedal crocodilomorphs from... It's okay. Trackway evidence for large bipedal crocodilomorphs from the Cretaceous of Korea.
Crocodilomorphs. In Korea, wow.
Yeah, but so they were still kicking around in the Cretaceous.
That's a younger island. That's very interesting.
Yeah, I can send this to you too if you want. It's neat.
Yes, please send that to me. I'd like to read that.
All right, will do.
Cool.
Of what? 2020? Okay.
Yep. So pretty recent. All right. Well, then
we will probably put up
done.
we will probably put up a new poll for our next vote. The last
vote? You did this last time. A vote on what? What are we voting on?
Well, it depends. Last time Dr. Dino's vote won. Maybe this time your vote will win. Your poll will win.
Well, I think perhaps, would you all like to hear about the difference between Brachys and Apatosaurus and Brontosaurus?
Oh, you mean Brontos and...
All three.
And that could be fun.
Discuss, like the encompassment of sauropods. Would y'all be interested in hearing about why and how Bronto is coming back?
Yes.
Because I've got some material I could bring for Brontos. Because I talked to Kerry Woodruff, who is big into sauropods. You know this. I was with him when he had Giardia in the middle of a Costco and ripped open a cinnamon roll pack. I know the difference of these big sauropods.
Sweet. Well,
I'm not a big fan of sauropods, but
really quick, Vandalia, did we already do derived sauropods? I don't remember.
We did the whole clade of sauropodia. We did the whole one big group.
Okay. I don't think we got to Titanosaurs though. So
I know
it's part of the Titanosaur episode.
I thought there was a thing about.
Yeah, we did three main groups.
I thought there was a thing about Brontosaur coming back.
Yeah, there is. we'll get more into that when we get to the details. But as I said, we did all of Sauropodia, we did all of Theropod, we did all of Ornithia. So we did the whole.
Or all of
No,
Ornithischia. I
There's
remember
no way
that.
to encompass all of them.
But now we're
No,
doing. Now
so
we didn't go.
just a second, Vin. Just a second. I'm just checking what we've done.
No,
Okay.
there's no
So
way
we-
to encompass all of them all at once. There's
We
so many,
didn't.
Vandalia.
Yeah,
There's so many.
And then we did the whole general. We didn't go deep diving yet.
Right.
Okay.
So just talking about the series, before you joined us, Nessie, we did talk about basal sauropods. We didn't get into the derived ones though. So that could be part of the derived sauropod episode.
That would be a cool episode if
Yeah.
I could help explain to everyone why Brontosaurus is coming back versus
Mhm.
Apatosaurus, because I was in Livingston. I did that. I know why she's coming back. So that might be a cool episode to do.
I mean, if we're all in agreement, don't put up a poll. We'll just do sauropods next, and we'll talk about Brontosaurus and Apatosaurus.
Yes,
sounds like
and
that's good.
Kate in the chat, yes, you are correct. It came back in 2015 via Carrie Woodruff, and I was on that paper. Who knows if I'm sticking around? But it. Okay. Yeah, but I think that might be a good thing to talk about. Would be Brontosaurus versus Apatosaurus.
Oh, cool. We'll plan that. We will plan that. We will plan that podcast once we on
in the
next
future.
stage. Yes.
Yes, in the future.
But in the meantime, never stop learning and enjoy the randomness. We will see you whenever. Bye.
Bye. Thanks.
Hey, thanks for watching my podcast or Let's Play. If you want to help support my channel, you can make a monthly or yearly pledge on Patreon, or just a one-time donation on Vimeo, PayPal, or Cash App. For those looking for something to wear, we have some shirts, hats, and other stylish things in our merch store. If you enjoy gaming, you can always follow and sub to me on Twitch. For those who don't want to give money, I have an Amazon and Steam wish list who can help the channel out. And of course, just liking, leaving a comment, and sharing this video helps more than you can imagine. And always remember to never stop learning and enjoy the randomness.